Hey everyone, thank you so much for watching this video. In the previous video, I explained how to integrate plugin price feed, and pull the data from the contract from the blockchain, right? So basically, this helped the community to understand how easy it is to bring the data from the external world onto your own smart contract. But it was very simple, right? So in this video, I'm going to explain how a Dapp can be set up. I mean, not a complex one, but again, this Dapp can be utilized for any use cases. Maybe you can take trading bot or synthetic assets platform wherein you will have to access a multiple price feed via a contract, and then it should seamlessly get you the value, give you the value, and you should perform the calculation to derive some synthetic assets, right? There are so many use cases which we can keep talking about. So here I'm going to explain a simple way, but again, the way we are going to pull the data would be much deeper. Okay, let's start. First, I just open few tabs. You can see remix tab and then plugin data feeds, wherein all the data feeds can be visible here, and XDC to USDT conversion, tab, and then Apotheum network, faucet tab, and then way to Ether converter tab. Okay, let's move on to this. We'll create a new folder, maybe since. Okay. First, we need to create a README file. I will explain what we are going to do in this video. We are going to set up a data feeds dolls.sol. Basically, this will allow the user to interact with the feeds platform and access any symbol pair value. For example, if you want to access XDC price, you can do that. If you want to access PLI price or Bitcoin price or Ethereum price, all prices data can be accessed via this simple data feeds.sol. That's an objective of it. Okay, to access multiple feeds pricing value. That's an objective of this. And then we will set up one ERC 20 contract for stable coin setup. And then we will have actual synthetics contract. This will allow us to do estimation, like for how much XDC as one stable coin can be created, and so on. And then we can also mint stable coin for the user. So we will just stop with this 3 line item. That is an objective of this entire video. Okay. Okay, so let me start with the data feeds. First and foremost, you have to do is just go to feeds platform. Just access any feed. Maybe we can take again XDC USDT, right? And then copy this program. So this is common for all the feeds platform. Only thing is different is this address, right? So I'm just copying it and then pasting it here in the remix. And I'm going to modify a few things here. But first, we are going to fetch only the latest price and then decimal value. I'm going to remove all other functions. Okay. I don't need this. I don't need this. And then I don't need this. I will rename this to data feeds. And then, yeah, it is not required. For which I am going to say decimals and then fetch decimals, right? And fetch latest answer. And this one will give only one value, which is event 8. Okay. Now, there are a few more modifications required. As I told you before, data feeds platform will help you to fetch multiple, price. For example, XDC price, Bitcoin price, Ethereum price, anything, right? To achieve that, the solution, you will need some kind of a mapping. You need to say, okay, hey, for this XDC, map this address, and for PLI map that address. Similarly, you need to have symbol versus address mapping, for which I'm going to set up a new mapping variable. Okay, and then I call it as key address. Okay, now I'm going to create a new function at key address. Then public. Okay, then I would say key address. Okay, equal to symbol equal to destination. Okay, so here we should get these two parameters from user, string memory symbol, then and the address destination, right? So now we have to this two, and of course this is not that you know um complex one, but still a function to get the value from the user and store it in the key address value. And now when someone is passing the symbol pair to this contract, it should fetch the corresponding uh, price value, right? For which I need to make some adjustment here. So I'm not going to get a feeds contract address from the user here, right? It's no longer required. All I have to do is I can put this feeds here and then say, hey, just get the value from key address, and the symbol value you can get from the user, right? So for which I'm going to say string memory symbol from user. Okay, so here instead of returning it here, I am going to get the value from in this line. Now we have the feeds, right? This is not a feeds actually. You should be into 56. We can say latest answer, latest price value, and this should be returned. Simple. Now the idea behind this function is if someone pass on, let's say XDC symbol, then it goes to this key address mapping and get the destination address of this feeds platform, and then construct the interface. Then it will fetch the latest answer from the blockchain, right? This will be returned later in Uint256 format. Similarly, we are going to do it for decimal. I'll just keep it here in this function and say decimal. It's going to be Uint8, and then I will just return it. Again, we need symbol to be passed on by the user. String memory. That's it. Okay. Now return this decimal value. Now we have this functions ready, right? Just very pretty simple way of bringing the value from the blockchain. Let's execute and then see if it works fine. First, I need to inject the Web3. It is done, which is an Apotheum network. I am going to deploy this now. Just deploy. So once it is deployed, you just need to, add a key address value first. So here I'm just copying this XDC feed address and paste it here. Okay, so XDC is getting added. Now let me go back to the feeds platform. And take a PLI USDT value. I'll take this PLI address, go to remix, then say PLI, paste. Okay. Now the PLI address is getting added into the contract. Once this is done, let's try and see if it fetching the latest price. Okay. So I'm just saying the PLI value Yes, it is. And the next DC value. Yes, it is. Similarly for decimal, right? PLI. So both values are getting pulled in this contract. Now this contract is ready. And of course, this is pretty simple contract wherein you can access multiple feeds card address through single contract. Now let's see how we can access this through other contract. Okay, so that we can perform some calculation and see as a user, if you pass on, if you stake some XDC, let's say 1000 XDC, how many stable coin which is pegged with USDT can be minted. That's an objective of this the next contract. Okay. So for which I'm going to create new file, synths.solve. Again, we need a few key lines. For example, here I'm going to say synths value, right? And I'm declaring another interface for this data feeds. Okay, and I need these two functions to be added. So I can access it in this contract easily. There are many ways you can create your contract. This is not the only solution. So you will find different ways to access the feeds value. But the objective of this demo is to explain how easy it is, you know, through this method. Now we have data feeds interface ready, and let's create synths contract. Now, first, let's create the constructor. So in this constructor, I need to override data feeds address, right? Dfeeds address. So I will say the dfeeds equal to I data feeds followed by the address value which I'm going to get it from user. Let's say address and then feeds value. So this will actually get user to should pass data feeds address here, right? And once it is done, the dfeeds will have access to this data feeds address, right? Now let's derive get estimation function. Maybe get estimation. So what we're going to estimate, see, if I pass 100 USDT, or sorry, 100 XDC, how many stable coin I'm eligible to mint? That's an idea. So which means 100 units I need to pass, right? Let's define it as units. And then we can say public. Okay, so which returns, we can say like, yeah, let's return the actual number of stable coins it's going to return in UN26 format. First, we need to get the symbol as well, because we have two value, right? PLI, USD, XDC, and so on. Maybe if user think like, okay, I want to estimate how many stablecoin I can mint for XDC. In this case, they will pass XDC as a symbol. Or if they want to find it for PLI, they should pass PLI symbol. So which means I need to get symbol value from the user, right? Now let's first retrieve decimal value for from the feeds. So I would say d feeds dot fetch latest answer. Sorry, fetch decimals. I should say symbol. So here the decimal will be returned by the d feeds contract for this whatever symbol we are going to pass via this get estimation function. Once this is done, what we have to do, we need to figure out how much the number of stable coin that this user is eligible to mint, right? For which we need to get the current price as well for this symbol. Current price is d feeds. Then let's pass this fetch latest answer and then symbol. right? Now we have current price and decimal, but current price would be in wave format. Similarly, decimals would be like how many decimals we need to uh, consider for the calculation to derive the actual value, right? For which we need to scale this price by multiplying this unit. For example, unit 256 followed by scaled price equal to, we can say current price dot, maybe we need to add a math function, right? Um, I think input Zeppelin contracts. We can check this in here and then neutrals. Okay, we have to get it from the other way around. Here, we need to have access safe math library from Open Zeppelin, and we just need to use this safe math for even 256 so that we can apply multiple functions, which will avoid overflow or uh, those kind of an error. So let's apply this. Now we have the scaled unit, right? Now we need to apply one more function and divide it by decimal so that we will get the actual stable coin that a user is eligible to mint, right? To get it, so let's apply this again. We will say, let's name it as actual value equal to scale price divided by 10 times of decimal, right? Now this will return the actual value that user is eligible to mint. Let's return and see this value, okay? And then we will continue with the contract. I'm going to test it very quick so that we can ensure things are working fine. So it says not found. Yeah, it's safe math. Yes, so the thing is, okay, so I have to make some, adjustment to the contract because safe math was giving an error in the specific version. So I just need to have some workaround. But now things are working fine. If you look at it, let's see how we can deploy and then access multiple contract. Already we have deployed DataFeeds contract. Now I'm copying this address and then uh, deploy the Synths by overriding the feeds contract address. Just change this XDC to 0x and then deploy. Once it is done, let's see what would be the estimation value. Maybe we want to pass 100 units, maybe 100 XDC. How much stable coin I can mint, right? I would say XDC. I think I need to make it as a view function, but let's see what is the value I'm getting. So which shows something different. Okay, I need to change this to view function and then see public get estimation. Then I'm passing the units value, finally symbol, and see how the value is getting derived. Okay, I'm redeploying it again. Best copy this address, feeds 0x, deploy, confirm. Once it is done, go to this get estimation, then say, then pass it on this Ethereum wave value and say XDC. So if you see, this is the value we are getting, right? Let's apply this in Ethereum V contractor. So which is 2.88 unit. I mean to say the stable coin. Maybe we can try it here. For 100 XTC, I would be able to mint close to 2.92 USDT. Of course, that is what it is showing here. 2.88, something like that, because it close to some zero point 0.4 differences that majorly occurs, based on the sync time. So currently we have XTC USDT synced around 6 minutes ago, right? That is a time difference. That's why you see 2.88, wherein the current XTC USDT conversion says that 2.92. More or less it works pretty fine. Let's see how much for PLI, for 100 PLI, how much it says 16024, right? Maybe you can try it out again here for 100 PLI, right? It says 1.63, which is close to, right? 1.624. So which is more or less correct. Now the get estimation works fine. Let's see how we can mint the ERC20 token for this value, for which I need to uh, have few more complex function. Let me go to the contract section and create a new contract. Maybe we can call it as um, stable coin dot sol. And as usual, we have to take this to line so that this works fine. Now let's create this contract by passing this stable coin, and we have to declare the XRC20, which is available right here in Open Zeppelin under contracts, under token, we have ERT20, right? So say import at Open Zeppelin slash contracts slash token slash ERT20 slash not solve, right? Now this ERT20 is imported. Now create the constructor and say I'm going to get string symbol and token name from the user, right? And I would say this has to be passed on ERT20 and name and symbol, right? Now the constructor is ready. It says a error. Yes, semicolon. Yes, the spelling typo error in memory, right? And then ERT20, again it shows some error. Reference declaration either didn't modified or not base class. So maybe we have to say is ERC20. Now the constructor is created and then it is ready to have a mint function created. Function, the mint, I would say I'm going to get a number of token to mint from other contract. I would say the units or amount, and then for whom this minting should happen, right? So then I would say address, and maybe we should declare this as external so that we can call it from other contract, and then return, maybe returns we can say true for now. Returns boolean. So let's call this mint function, which is getting invoked from ERC20 Solidity contract token standards. So for which I'm going to say for this user mint this many token, right? I'm not going to put any condition for now. I'm just going to show you how it works. Let's deploy this. But the point here is this contract should be invoked only by the Synths contract. It should not be invoked by other contract. For which what we can do, we can say, while I deploy this stablecoin contract, I need to pass on the authorization address, authorizer maybe, right? So let's declare this address public, immutable, and we can call it as authorizer, right? And then pass this authorizer. And now we need to declare a modifier. Then say only authorizer. And we can say that require, it should be only the message sender should be equal to authorizer. Only authorized contract allowed. Okay. And then we should say this. So all the modifier is ready. Now let's pass this modifier here. If you see, the mint function now can be invoked only by the authorizer contract. And when I deploy this stablecoin, I would pass on the authorizer contract, which is nothing but the Synths contract. Let's see, let's compile it and then see how it works, okay? So I'm going to pass this stablecoin. I will say test step, this tab, this table, authorizer, it's going to be the Synths address 0x. So now the transact should invoke the contract MetaMask and then we can deploy it. So once it is done, now you have the stablecoin contract also created. And see who is authorizer. It's going to be the Synths contract. And if I try to mint, it won't work. Let's see. I will say maybe, this many volume of USDT should be created. So I will say create this to this address, the same address. It should revert error. See, it says that only authorized contract allowed to mint, right? Which is good. Just as expected. Now, let's go back to our Synths contract. But the problem here is, again, we have to redeploy because I'm going to modify this contract a bit. And we have to redeploy this Synths, and then we have to redeploy the stablecoin as well with the new Synths address. Okay, now let's have calculations, which will create a list of, or we can do one thing. Instead of create a new function, we can customize this get estimation functions and call the stablecoin contract here so that it can access the stablecoin and call for the minting operation. Okay, that is an objective. Now let's create an interface again for this stablecoin. Okay, and I'm going to call a mint function. Okay, so I will just bring it here. I will remove this only authorizer. Now the stablecoin can access the mint function from the actual stablecoin contract, for which I need to define. So here the point here is, first we have to deploy synth, but synth should have a knowledge about the stablecoin contract address. But the point is, maybe let me put it in readme so you understand. Okay. So see, first the flow should be like this. Uh, we have to deploy synths first, and then deploy synth first, deploy stablecoin, and override synth address. Right now, synths should know stablecoin address. For which, what we are going to do, we are going to create a key mapping variable here, right? Mapping, I would say again, string followed by address. Let's call it as key address. Okay. And again, we have to create a function add key address, followed by public, and then you know let's get the value from the user, string memory, symbol, address, destination. Then override this or map this with key address value, symbol equal to destination. Right now we have this destination value as well, but it's giving error. Let's see what is it. Okay, it is double hyphen. There should be single. Okay, so it's an address, key address variable. Now when the owner is calling this, let's say like any user can call this add key address and then map the uh, as stable coin address value pair. We can say maybe instead of stable, yeah, we can pass simply stable coin, right? Now, once this key address is ready, now as a user, we need to customize this function so that it can calculate as well as it can call the stablecoin contract and mint the number of token, okay, into the corresponding user wallet. Let's do this. So as soon as you call this get estimation, maybe instead of symbol, what we can do, we can override um, the stable as a key, and then we will pass destination as an address once we deploy this synthetics contract. Okay, I'll explain. I mean, I'm sure it will be a bit confusing now, but try to stick with me. I will explain as and when I move forward. Okay, now I'm just hard coding. I'm not going to get any symbol from the user, but the address has to be mapped. I'm going to call this function only once, of course, because we are going to have only one stable coin, which is getting generated via this synthetic contract, right? That's why I'm hard coding it for now. But for your requirement, you can have a number of symbols and destination accordingly. But here I'm going to have only one stable contract. Okay, now the reason again I'm hard coding it here because in get estimation, I need to derive the contract address. Accordingly, I need to invoke a mint function, right? So here, let's see, do this. We need to mint. We need to call for the minting function, right? So for which I'm going to say, hey, you need to mint. Let's do this here. Yeah, so I'm going to call this interface iStableCoin stable, right? Stable and then I would say stable or boolean, right? Flag equal to, because the actual minting function will return the boolean value, right? I need to say the return value true, maybe just for this term purpose I'm not coding it to true. Going back to synthetic assets, and now I'm just going to call this, okay, the stable followed by the key address. Or I think I don't need this. Instead, directly, I stable coin in bracket key address, right? This key address value stable. So what will happen now when we pass this table, it will get the address which is getting stored in the add key address method, right? Now I will have a stable coin from which I should call the mint function, right? Mint function, and this mint function will have, I think the codes is missing. Yeah, the mint function should have message.sender followed by the actual value to be minted, right? So let's see what is the error. It's this invalid type argument function called invalid implementation. Okay, mint message.sender and then actual value. Okay, ulta. I'm just passing the value differently, so it should be otherwise. Actual value, comma message.sender. Now you can see that the error should be gone. No, I don't think so. Let me check. Function cannot be a view. Yes, because we are changing the state value, right? Blockchain state value, right? So we should not be view. Then public returns event 256, so which can very well work. Let's see, instead of having get estimation for naming conversion, let's change it to you know estimate and mint, right? Estimate and mint. That's the function name, and I'm just saying actual value and then flag. Okay, so here I'm just saying I'm getting the actual value and then followed by whether it is successful or not. Of course, I would always get true when the min function is works fine. Let's see if it works or not. First thing first, we need to data feeds is constant, which we already deployed, so nothing to worry about. But we have to remove synthetics and then stablecoin, right? First, we have to mint or first we have to deploy the synthetics contract. Copy this over at the data feeds address and deploy. So once it is done, the synthetics contract is deployed. We need to copy this address, then go to stablecoin, then deploy this. Okay, again here we have to override our symbol name. Maybe we can say test symbol, and then test token followed by the authorizer, which is the synthetics address. Okay, now once this stablecoin is deployed, copy this stablecoin address, go back to synthetics, and then add it in key address function, which means we are just telling the synthetics contract, hey, this is what the stablecoin contract address. Now, whenever user calls the estimate and mint function, you should invoke corresponding mint function. That's an objective, okay? So I'm just saying add key address, then call the function. So once it is done, I have this stuff created. Now let's go ahead and then see if it works. Okay, estimate and mint. So what I'm going to do, I'm going to pause the actual unit, like number of XDZ, right? Maybe we can say 300 for a 300 STZ. How many USDT should be minted? 8.68, right? Let's see how it works. So I'm going to call this, copy this, and remix this, paste it, and then say XDC trigger. So it is calling this estimated mint function, confirm it, wait for a second, and it's done, right? It's perfectly worked. Let's see whether the token is actually minted or not. Go to tokens, right? Now copy the stablecoin address, contract address, go to your minter function, MetaMask, and then import the token. It says not identified. Okay, let me try again. Invalid address. Okay, was my bad. I was having capital X. Now things should work fine. Let's see. Yes, it is. See, 8.64 stablecoin has been minted for number of token which user wanted to stake. Of course, there is no staking done here. I'm just trying to show how the actual calculation is happening, and then user can mint a new token economics altogether. Overall, this is how the entire demo, right? Of course, this is too many ifs and but, and too many contract are involved. Of course, this three contract, but much more complex contract can be created. I just to summarize what we have seen in this video, we have created data feeds contract, which actually helped the user, to store multiple feeds symbol and then corresponding destination address, through which user can access PLI value, XTC value, Bitcoin value, anything. You can put everything in this data feeds and then access it via synthetics contract. Again, synthetics contract, we created a stable data feeds interface and then stable coin interface, and we created a add key address again to store the stable coin contract address so that we can mint it later. We can call the minting function later. But in the stable coin, we have defined only authorizer where the stable coin can be minted only by the synthetics contract. So overall, this is how the things work, right? But if you see on a high level, plugin price feed can be very easily integrated in a complex contract as well. And there are so many use cases. In upcoming videos, I can explain different use cases, maybe for the deepin or for supply chain, like which we can keep adding. So if you like this video, comment and share it with your fellow ecosystem partners and see how we can do better. Thank you so much for watching, and bye-bye.